Hello, Gary here. I'd like to just show you my hybrid swing sliding gate system, or my smart gate system here, which has just been completed today. Here we have a 2-leaf section, which is a pedestrian gate, and a 3rd leaf section, or 1-leaf section here, which is a sliding gate. The pedestrian gate will open here manually, just allowing pedestrian access without having to use any motors. The motors themselves came with these fobs, which they can be controlled with. However, the system has been designed in such a way where you can press hard buttons in the home, or you can use voice control. In this case, it's Amazon's Alexa, just to demonstrate how the gates will work with voice assistant. Computer, open gates.
Opening gates.
As you can see here, the pedestrian gate opens first, and there's a 5-second delay on the sliding gate. The sliding gate itself will slide all the way back, clearing the pillar, and will stop using a magnetic limit switch. The pedestrian gate here will stop using resistance of the motor. So once the motor can no longer push or pull any further, it will automatically cut itself out. Each gate can also be controlled individually. So to demonstrate that, the computer, close sliding gate.
Closing sliding gate.
As you'll notice here, we have an anchor and also a U bracket here, which will slide into position here. The reason for this particular setup is to prevent anybody from lifting the gate off the track when it's closed. The pedestrian gate has a similar setup, although for a different reason. We have an anchor locked into place here, and you'll see as the gate is closing, leaf 1 has an L-shaped bracket attached underneath. The idea here is that when the L-shaped bracket presses against the anchor, it will no longer be able, the motor will no longer be able to push any further and will disengage itself. Computer, close pedestrian gate.
Closing pedestrian gate.
And both of the gates close themselves, because this 2nd leaf is attached using 2 true close self-closing hinges, each rated for approximately 70 kilos. The gates themselves, everything put together, the wood and the steel, weighs approximately 130 to 140 kilos. Each of the motors or the kits come with fobs. This first fob here will control the sliding gate. So we'll just press that button there and we'll just stop it in place. And we have the swing gate that will activate there. And we'll just stop that in place. The motors are also controlled using hardwired switches. How that is achieved is by running control wires to each of the motors. The sliding gate itself has a built-in control unit, a built-in PCB or motherboard. However, the pedestrian gate has its motherboard built into this box here on the right. So the control wiring, or the signal wires, are run through this galvanized pipe, which is attached to the wall and runs to each of the motors. As well as the fobs and voice control, the gates can be controlled using the hardwire buttons, which are placed inside the doorway, just above the doorway. This left one here controls the sliding gate, and this right one here controls the swing gate. It should be noted that the buttons used in this case are momentary or unlatched buttons. This essentially means that when the button is pressed, it does not lock into position, and when the finger is removed,
the connection is broken. This means that when the button is pressed, a connection is made, and when it is released, the connection is broken. So I'll just demonstrate that now. I'll first press the pedestrian gate. And there we have that opening. And if I press the button again, it will stop the pedestrian gate. Exactly the same happens when I press for the sliding gate and press it to stop. The motors are now reversed in polarity and will close when the buttons are pressed, like so. The motors can be controlled by the app, which essentially is connected on the same loop as these buttons. These buttons are connected to a Wi-Fi relay system embedded behind this wall. Here you can see the control system diagram layout. Where possible, I have used the very same components or very similar components as have been used in this system. Number 1 here you can see a typical consumer unit. Numbers 2 and 3 are the swing gate and sliding gate motors. Number 4 are the Rfid fobs which control the swing and sliding motors. Number 5 is the Wi-Fi relay box. In this case, it's the Sonoff 4-channel Pro unit, which has 4 Wi-Fi relay switches built into it. Number 6 is the Wi-Fi router. And you'll see the items marked X down at the bottom left-hand side are all Amazon related products. You'll see the Amazon Alexa app, you'll see the Amazon Alexa Show, and you'll see the Amazon Alexa Dot. You'll also see in the center of the diagram B1 and B2 for the buttons. B1 is connected to the sliding gate motor and B2 is connected to the swing gate motor. It is important to note that the switches are in between the Wi-Fi relay box and the motors. This is important because if the switches are after the relay box, they will simply not function. They need to be able to create and break a circuit in between the relay box and the motors. The Wi-Fi relay box is one of the main components in the system. It allows the user to control the motors using voice control or tap functions through an app. All of these are connected through the router. However, Wi-Fi can and does go down, so it is important to have backups. The motors do come with Rfid remotes, however these can easily go missing. So in this case, the buttons were fitted which are hardwired into the system, so if the Wi-Fi does go down and the remotes aren't to hand, the system can still be controlled. The Wi-Fi relay module was connected to the motors via their motherboards. In this case, Relay 1 and Relay 2 were utilised. The normally open and common pins were used to connect to the motherboards on the common and active pins. When activated, the relay turns on and off using something called inching mode. This is essentially the same as a non-latching button. It turns on and off. This makes and breaks a circuit, and in turn, the motherboard tells the motor to spin. From concept to completion, this project was certainly a journey. In the beginning, there were measurements and design. Then came the calculations, the electrics, the excavation, the materials, the logistics, the pricing, the manufacturing and assembly, finally the finishing and testing. I set out to do more than just a research project, and in the end, I'm quite glad that I did. I have something to look at, something to be proud of, something that will be there for many years to come. I hope you've enjoyed this video as much as I've enjoyed making it. Thank you for watching.